Hi, and welcome to PodRocket, a web development podcast brought to you by LogRocket. I'm your host today, Paige Niedringhaus, and today we have a returning guest, Dominik Dorfmeister, a software engineer at Sentry and open source maintainer of the TanStack libraries. And he is here to talk about the useless useCallback. Welcome back to the show, Dominik.
Hi, I'm glad to be back. Thanks for having me again.
You have written a very interesting and a little bit maybe controversial blog post recently about useCallback, which has spurred a lot of controversy, I think, just since its inception as a hook in the React ecosystem. So let's talk about why you feel that it is useless and also the useMemo callback. Both of those were described in your article as totally pointless. So can you talk a little bit more about why you feel that way and, how it's maybe become overused in modern React code bases?
Yeah, so I'm usually not that definitive when it comes to framing things. And obviously, we also have to take this with a grain of salt. Totally useless or pointless is obviously not like in a nutshell what you can say about these hooks. But from the way I've seen those grow in larger code bases is often that things start out with a little bit of memoization that is needed in a specific situation, mostly for referential stability to speed things up. Maybe you have a memoized component that gets a callback call, and then you need to wrap that in useCallback so that you don't break that reference stability between renders. And usually when this gets introduced into code bases, there's no ill intent behind that. People try to make things better and faster. But the problem I have with that, so to say, is that I think it doesn't evolve well over time. And that actually starts with React.memo, which is the other article, the uphill battle of memoization that I've written, where kind of like you start having React.memo and then you need to memoize all the props. And then what components usually do over time is they evolve and we add more props. And then it's very easy to just break that memoization. And once you are at that point where you have all props memoized except for one, none of this actually works as intended. And this is what I've seen in older code bases, in larger code bases a lot, that whenever I see a use callback somewhere, I try to see why it's there. And then I go to the component that is memoized. And then I actually see that everything would work just the same without this use callback, because in that instance, it doesn't do anything. And that's what I've seen a lot. And that's why I wrote the article.
So really, people are trying to improve the performance of their applications. But like you said, as the code base grows and evolves over time, it just adds another layer of complexity that isn't actually doing what they intended it to do originally.
Yeah. And that is the thing that I like to try to strive towards the most, is actually to have the code readable and maintainable, if you will, and adding a lot of use callbacks and use memos that you only need for referential stability does the exact opposite. And apparently, these things don't get measured, because if they were, or maybe they were measured when this was introduced, right? So you see something is slow, you measure it, you find the culprit, you memoize it, it gets better. But then you don't actually measure this over time, because otherwise you would see when it gets worse again. And I found a lot of usages in Sentry, for example, in the code base where we have use callback, and a bunch of times I just removed them because they didn't do anything. And things were also working the same. There's this kind of situation where I'm wondering, why do we have them in the first place? But this is just how things evolve. And that's kind of a problem, I guess.
So how do you weigh the trade-off then between ensuring referential stability and keeping the code simple and maintainable?
Yeah, so one of the things that actually I think gonna really help here is the React compiler, because I don't think that the memoization itself is a bad idea if you want to make things faster. It's just very hard for humans to do consistently and everywhere throughout the code base, especially when props like children are involved, when inline objects or arrays are involved, and when functions are involved. So the React compiler just changes the game by really memoizing everything. And if memoizing everything were easy, we would also do it. But then when we humans try to do it, we do almost everything. And almost everything is the worst you can do. And also it adds all these overheads to your code base that you have to read and parse and understand why it's there. And that's worse than just trying to get by without those. But with the React compiler, I think what people have seen is that it does create a very good performance benefit. And in that case, I think that's the best situation we could be in. But if we're not using the compiler yet, I think the question is really like, why do I need to ensure referential stability in the first place? It is because I have a memoized component. And or I have a useEffect where I call this function, but yeah, useEffect is a different kind of beast. We shouldn't also probably overuse that one. But, I looked at the Sentry code base just before, and I've only seen, this has 1 million lines of TypeScript code, and I've only seen 27 components that are actually wrapped in React Memo. So I think there are situations where you might need it, and then you need to be very specific about it and maybe do a proper naming on top of that. And then maybe make sure that those components that you memoize don't take any props at all. You could ensure that with a lint rule, or only you don't allow functions or whatever. But if you apply this surgically, really only in situations where you know it's needed, then you should be able to get away with not using it anywhere at all. Because as soon as you try to, this feels a bit slow, I'm going to memoize this, you are on a path to making your code base probably a bit worse than without it.
So you said that within the Sentry code base, there were only 27 instances that you could find. When do you think it is worth the effort, or is it really ever worth the effort to use something like useMemo?
So for React Memo, I've seen a couple of usages around tables and virtualization. I think maybe that if you have a library, like a virtualization library that expects the rows that it renders to be referentially stable, then obviously that is something you need to do apart from that. I think there are very often ways to not reach for React.memo.
Elizabeth here, production assistant for PodRocket. We're running a listener survey to help shape future episodes and make the podcast a better experience. It shouldn't take more than 5 minutes of your time, and you can find the link in the description.
If a team like in Sentry, for example, was using either useCallback or useMemo, how common do you think it would be? Or, what can they do to avoid either breaking the referential stability and then completely invalidating the useMemo or the useCallback, or at least keeping track of it beyond performance timing? Do you have any examples or best practices to keep an eye on that sort of thing to make sure that it's still doing what you intended it to do?
Yeah, I think that's the hard part. And that's also why I think it's not worth doing it. I'm not saying we need a lint rule that forbids them completely, but every time, at least when I see them in a pull request, I'm questioning, why do we need this? Why is it there? What does it do? Do we need the referential stability somewhere? Of course, there are situations, especially for useMemo, which when it's not about referential stability, but when it's about having a really expensive calculation that you might have, where to define what expensive is and how often it runs or shouldn't run. But then, of course, useMemo has a different use case, and the prime use case about not doing the work too often. But if we only use useMemo and especially useCallback doesn't have that, right? That's only for the referential stability because the function is always created anyways. Then it's kind of do we need that? What's the situation? It's probably going to be a memoized component, or it's a useEffect, and I'm tracing down the steps. And in the one example of the blog post, I actually found that it was not working, and the effect was running on every render anyways, even if we have all the memoization in place, because there's always, or very often, something that kind of bypasses this. So yeah, my rule of thumb is basically question every usage of useCallback that you see. Why is it there? Why does it get added? I know that's hard, and you need to be vigilant with those things. And the other thing that I try to do is, if we have them or need them, I try to not make them dependent on props that come into a component or a custom hook. Because once you have that, you basically offload this kind of responsibility to the consumers. So you're saying, I have a custom hook and that takes in an array of things, and then I'm using these as my dependency to my useCallback or useMemo. But the call side of this custom hook needs to know that they have to memoize the things that they pass in from the outside. And that's really hard because you need to, maybe document it or name it in a way that it indicates it's memoized, because otherwise the call sides won't know. And maybe you are now fixing all the call sides that you have at the moment, but people will add new call sides maybe. Otherwise, why is this a shared custom hook? And then it will break again. So that's the situation where if you need this, try to make it self-contained and try not to expect people to know that the arguments they pass to you have to be memoized, because how could they know? That's the hard part.
Which comes back to your original point of just use React Compiler, which will take care of it all for you, so you don't have to think about it.
Exactly. The hard part about React Compiler is to actually be compatible with the React Compiler. So you need to adhere to all the rules of React, basically to the letter. And there are some situations that are hard, especially if you haven't watched out for them like at all in the past, like reading from refs during render and so on. So there are like nuances where the React compiler we just probably bail on doing things. But in that case, I can recommend right now using the ESLint plugin for the React compiler that will tell you right now where there are things that you're doing, things that the compiler will not be able to optimize. And then you can try to work on those.
Oh, nice. Is that an ESLint plugin from the React team themselves, or is it a third-party just helper function?
No, it's from the React team themselves. It used to be a separate plugin called ESLint plugin React Compiler, but I think with the latest version, they just moved it into the ESLint plugin React. And there is now a React compiler rule that you can turn on. And then it's not the fastest ESLint rule, so it's more on the slower side of things, but it will tell you when you're doing something that the compiler will not be able to optimize. And I think that's a good step forward.
Yeah, absolutely. That's worth it. Well, cool. So one of the things that you mentioned in your blog post was instead of using useCallback, you used refs instead. So you present a latest ref pattern as an alternative to memoization. So are there any pitfalls or edge cases that developers need to be aware of if they kind of transition to trying to use this instead of memoization?
Yeah, so the latest ref pattern is something I actually read on Ken C. Dodd's blog the first time a couple of years ago. And basically what it does is if you have to depend on a prop that comes in and you don't want to create a callback that is reactive to this prop, so it needs to be recreated every time when this prop changes. But what you want to do is you want to have a function, and when this function is invoked, you want to actually just read the latest value at an imperative access, right? This is kind of like where React is usually declarative and everything gets recreated when something changes and it stays nicely in sync. There are situations where we sometimes just want to call a function imperatively and then read something directly from it. Like when you have for example, a Zustand store, you can call .getState and just imperatively grab whatever is in there without subscribing to it. Now, obviously, you wouldn't do that during render because then things get out of sync. But if you are in a callback function that gets invoked imperatively, you also want to just give me the latest value that I have right now. And if that's the case, then the latest ref pattern can be really helpful because what it basically does is it takes the prop and just writes it to a ref in its separate effect and then updates it all the time. And then in your callback, you're just going to read from the ref, and the ref doesn't need to be added as a dependency array. The ref is like just a mutable object where you can write towards, and you basically leave this React declarative way of doing things into a more imperative way. And you can just then access the ref in the effect or in the callback. And that's been very helpful if you also apply it sparingly and internally. Like you wouldn't want to create that and then pass it around to child components or something like that. And I think the React team has actually like also considered this in the past where they had this use event hook, I think that they wanted, and then specialized it towards something called useEffect event. That is React hook that is currently in the, I think, release candidate or like preview build of the next release. So it's something that's still unstable. So it's not an official hook that is in React 19. But it's something that you can try out, and that basically comes from the fact that we sometimes want callbacks that are referentially stable while still reading the latest value of a prop or another field. And for this right now, you would need to work around it. But if this becomes like a built-in thing, then you wouldn't need to apply this manual pattern anymore. So that's, I think, a really good step forward too.
Excellent. That's actually what I was going to ask you about next, was if you could talk a little bit about useEffect event, but I think you've already covered it.
I think doing this manually with the latest ref pattern is a lot more work, right? You need to wire up all these things correctly. But since you asked about pitfalls, I think there is some versions that actually use a layout effect instead of an useEffect to update the ref, because effects actually run like bottom up. So children effects run first. And if you take this callback and then maybe pass it to a child component and then use it in an effect there, it might run before it's actually updated by the parent. So that's why they use a layout effect, but then you have the same problem if you have a layout effect in the child component. So it's like trying to get the timing right with how this works internally in React. And as long as you have this ref and it just stays in the same component and you don't pass it around, again, that's I think why I said we shouldn't pass these things around. If we do these workarounds, they should be centralized in one place and not abstracted away so that we can then do whatever we want with them. But it's kind of like once you have useEffect events, the timing will always work because the React team just internally makes sure that this is a specific use case that they're covering. And we don't need then those workarounds anymore.
Got it. So it's helping to prevent some of those race conditions that can happen sometimes when data is being fetched from multiple places, but it's coming in different orders than originally intended.
I haven't really seen those edge cases, just a theoretical thing that I think if you use this would be good to be aware of.
So you were saying that when you do PR reviews for Sentry, if you see a useMemo or a useCallback, you're immediately skeptical and take a really critical look at that. So do you have any team guidelines or tips that you would share that other developers can use to help do their own PR reviews and make sure that these things that are going into the code base are actually doing what they thought they were?
Yeah, I think if everyone's aware of the whole situation, the problems, the upsides and the downsides, then what really helps is just not overuse those useMemos and callbacks. And if you add them, what I like to do is when I make a PR is I leave a self-review on that PR. So I go through my own PRs and leave comments for the reviewers explaining maybe why I'm doing this. And in those situations, I would probably just outline why some memoization or useCallback is actually needed here so that we don't have to go back and forth between why do you do this? Oh, I'm doing this because, okay, gotcha. Especially when the team is like time zone differences like I have with my team at Sentry, we would be wasting like 2 days discussing why are you doing this back and forth. So I'm trying to be upfront about some situations where I think that people might have questions upon. I'm just outright posting a PR review for myself about the things that I did.
Sure. That's a great way to do it. My teammates and I do that as well for things that might be flagged as strange or why did you do this code?
Yeah, and I think that's kind of like a cheat code sometimes because when I do this, I kind of have to think about why I did things and I realize, okay, maybe this isn't ideal. Sometimes when I try to write a comment about my own code, I figure out that, actually I should maybe change this a bit, or maybe I read through it and I find a better way to do it. Sometimes I find some code that I only left for tests and I want to for debugging and I want to remove that. So before I waste the time of everybody else, I open the pull request as a draft PR and then go through it myself. And only then when I'm satisfied with that I haven't left anything and that this is as good as it can be, I'm giving it to others for review.
Yeah. I mean, self-reviews, and for whatever reason, it's different looking at your code in a GitHub PR versus in your VS Code instance or wherever you prefer to actually write it. It just helps you, like you say, catch things that you didn't notice as you were putting it together. So, yeah. Thumbs up for the self-review for sure.
Yeah.
So one thing that I wanted to ask you, and this may be why we've gotten into this weird state of useCallback and useMemo and people not really, or maybe overusing them, is the React community docs. Do you think that they might unintentionally encourage people to over-memoize or try to over-optimize before they really need to?
No, I really don't think so. I think people don't read the React docs enough. They're very good. The new docs are really good. There's this one article, there's one page that I always link towards. It's called You Might Not Need an Effect. And it shows all the usages. It's a bit of a different topic, but it shows all the usages that you can do before you have to reach for a use effect. And that kind of eliminates so many use effects from your code base if you just adhere to what the React docs say. And I think for memoization, regarding useCallback, they're also saying that the compiler can do this automatically. You only need to do this in specific situations when you really have the need, and so on. So I think the React docs are really on point in that regard. I just wish people would read it more.
Good advice. All right. So is there anything that we haven't talked about in terms of useCallback or useMemo that you think people should be aware of or developers should keep in mind as they're using or potentially not using these things?
I think just being aware of that it's probably not necessary to do it or just question why things are there is already a very good first step. I've seen situations where people just do things because that's how it's done in the code base and we do it everywhere and not really understanding why things are done. I know there's also a movement of people saying we memoize everything by hand because then we don't need to discuss why something is memoized and why it isn't. And then I'm seeing useMemo calls on, I don't know, a variable that does a calculation of two numbers or whatever, and then that gets memoized and things like that. But if you really do memorize everything by hand, you also need to memorize things like children or other React nodes that you do. And that usually doesn't happen because this is something that it gets done very rarely. And that's what the compiler does. So it really does it from top to bottom for everything, including React nodes, not just the props of it and so on. So that's where all of this, advantage comes from. And maybe one thing that I think I purposefully didn't highlight in the articles that I wrote is that some people say that you shouldn't use callback or useMemo because it also has like an overhead of doing in terms of useMemo needs to actually store the old value, needs to do a comparison. UseCallback needs to create the function and then do a comparison of the props and so on. And while that's true, this is not something that I would like to focus on when thinking about do we need useCallback or not? Because if the useCallback is one that is necessary to really avoid something from happening, and you are aware of that this is self-contained and this works, and you maybe also hopefully measured it and so on, then it's a good use. But I would really rather focus on the readability of the code and how much code we can actually delete if we don't need to wrap everything in useCallback or useMemo just to keep the referential stability. It's not that much about, this will create a little bit more memory or it will have to do a bunch of small comparisons. Yes, that's also true. But if that were a problem, the React compiler couldn't really work at all. And I think what they found out with the React compiler is that there is a very small overhead in terms of memory on the first render run because it is memoizing everything, but it's not as much as they actually thought it would be. And then on the upcoming re-renders, it's actually a lot better than it was before performance-wise. So all the talks about, we shouldn't memorize this because this creates unnecessary overhead if it doesn't work. That's not the problem. The problem is that we have to read this and we have to maintain like all the dependencies up to date all the time. And that's the topic I wanted to focus on with the article as well.
Excellent. Well, Dominik, it's been great having you on the show today. If people want to get in touch with you, learn more about what you're doing, or talk more about useCallback and useMemo, what are the best places to reach you online?
Yeah, I'm very active on Blue Sky. You can find me there as tkdodo.eu. I also have my blog where I have a comment section on my blogs on tkdodo.eu. You can reach me there. I'm on the 10-stack Discord a lot, obviously, for all the maintenance of the libraries that I do. So reach out to me in any of those places.
Great. Thank you again for joining us on the LogRocket podcast. It's been great having you back.
Yeah, thank you for having me. It was awesome.